Hello friends, in today's class we are going to see the topic thermocouple. So thermocouple is a device which is used for the measurement of temperature variations. So thermocouple is also a temperature transducer. Thermocouple is a device which is used for the measurement of temperature variations. So generally we know that the transducer is a device which is used to convert the non-electrical quantity into an electrical quantity. So the definition of transducers is it converts the non-electrical quantity into an electrical quantity. So this thermocouple is an active transducer. So it is also a temperature transducer which converts, it is a temperature transducer, converts thermal energy into an electrical energy. So it converts the thermal energy into an equivalent electrical energy. Next we will see the principle of operation of thermocouple, which is used for the measurement of temperature. So the principle behind the working of thermocouple is based on thermoelectric phenomena like Seebeck effect, Peltier effect and Thomson effect. So the principle behind the working of thermocouple is based on three thermoelectric phenomena like Seebeck effect, Peltier effect and Thomson effect. So in general a thermocouple is a transducer, temperature transducer. It consists of two metals joined together to form two junctions. So it consists of two metals joined together to form two junctions. So here the one junction is called the unknown body. One junction will be the unknown body where the temperature is to be measured. So where the temperature is to be measured is called as unknown body. Also we can call this junction as hot junction where the temperature is to be measured, or we can also call it as measuring junction. And the second junction is the known junction or the known body. We can also call it as cold junction or reference junction. So it has the two metals joined together to form the two junctions. One is the unknown body where the temperature is to be measured, that is hot junction, and the second junction is the known body. It is also called as cold junction, which is taken as the reference junction. First we will see the first thermoelectric effect, which is the Seebeck effect. What is Seebeck effect? So this Seebeck effect states that when two different or unlike metals are joined together at two junctions, an EMF is generated at the two junctions. An EMF generated at the two junctions and an electric current flows around the closed circuit. So it states that when the two different or two unlike metals are joined together at the two junctions, an EMF is generated at the two junctions and an electric current flows at the closed circuit. And the amount of EMF generated depends on the different combinations of metals. So the amount of EMF generated is different for different combinations of metals. So for different combinations of metals, the amount of EMF generated is also varies. Now let us consider two different metals. You are having two different metals, metal 1 and metal 2, which are joined at the two junctions. You are having two metals, metal 1 and metal 2, which are joined at the two junctions. So this junction is taken as the hot junction and this one is the cold junction. Now let us consider the metal 1 as copper and the metal 2 as iron. When two different metals are joined together at the two junctions, an EMF is generated at the two junctions, that is the hot and the cold junction, and a current flows through this circuit. The current flows from metal 1 to metal 2 and from metal 2 to metal. Example, the metal 1 is copper, metal 2 is iron. If a current flows from copper to iron, if a current flows from copper to iron, that is, if the current flows from copper to iron at the hot junction and the current flows from iron to copper at cold junction. So the current flows from copper to iron at hot junction and from iron to copper at cold junction. So if a wire is cut off at the copper junction, so if you cut the wire at the copper junction, so hot junction, cold junction. So if a metal is cut at the copper junction, so an EMF appears across this open circuit. That is, the EMF in the open circuit is directly proportional to the temperature difference across the two junctions, that is hot and the cold junctions. The EMF will be proportional to the difference in temperature across the two junctions. So the difference in temperature T1 and T2 is directly proportional to the amount of EMF which appears across this open circuit. So Seebeck effect is nothing but when two different or dissimilar metals are joined together at the two junctions, an EMF is generated at the two junctions and an electric current flows in the closed circuit. The amount of EMF generated in the circuit varies depending on the type of metal used for the circuit. Second, we will see the Peltier effect. So in Peltier effect, when two dissimilar metals are joined together to form two junctions, and if an external EMF is connected within the circuit, then the current flows through the circuit. So when two dissimilar metals are joined together to form the two junctions, and if an external EMF is connected within the circuit, then the current flows through the two junctions of the circuit. That is, when current flows from copper to iron at junction T1, heat is absorbed, making the junction T1 hot. So when the current flows from copper to iron at junction T1, heat is absorbed, making the junction T1 as hot. Next, when current flows from iron to copper, it is at junction T2, heat is liberated, making the junction T2 cold. So when the current flows from iron to copper at junction T2, heat is liberated, making the junction cold. So when an EMF, external EMF is connected across the two junctions, that is the hot and the cold junctions, it is temperature T1 and T2 is the cold junction. When the current flows from the copper and iron, current flows from copper to iron, heat is absorbed, making the junction T1 hot. When current flows from iron to copper, heat is liberated, making the junction T2 cold. And the third one is the Thomson effect. Thomson effect states that when a current flows through a copper conductor, having thermal gradient along the length of the conductor, heat is released at the point where current is in the direction same as the heat flow. While the heat is absorbed at a point where the current flows in the direction opposite to that of heat flow. So when a current flows through a copper conductor having a thermal gradient along the length of the conductor, heat is released at the point where the current is in the same direction as the heat flow, while heat is absorbed at the point where the current flows in the direction opposite to that of heat flow. Now let us see the working of thermocouple. Let us consider two metals, two dissimilar metals joined together at the junctions. Let us consider the metal one as metal A and metal B. So it has a hot junction T1 and cold junction T2, and EMF generated is measured with the help of a voltmeter. So metal A and metal B are the two dissimilar metals. So voltmeter connected across the circuit to measure the EMF induced. So hot junction is nothing but the measuring junction, and cold junction is taken as the reference or the constant junction. So here the thermocouple measures the voltage generated between the two junctions. It measures the voltage generated between the two junctions. The total EMF produced depends on the type of metals used, metal A and metal B, and the temperature difference across the two junctions T1 and T2. So it measures the amount of EMF generated between the two junctions, and the temperature difference between the two junctions and the type of metal used will produce the total EMF, which is measured with the help of the voltmeter. Now let us see the mathematical relation between the voltage and current in the thermocouple. So the EMF produced in thermocouple is given by E is equal to A into del theta plus B into del theta square. So EMF generated in the thermocouple is given by relation E is equal to A into del theta plus B into del theta square. Here del theta is the difference between two junctions in degrees Celsius, and A and B are the constants. Generally for linear relationship, the value of the constant A is always greater than B. So the value of EMF induced E will be equal to A into del theta, since B is neglected. So from this relation we can get the change in difference in temperature between the two junctions is equal to E divided by A. So del theta is the difference in temperature between the two junctions. So del theta is equal to E by A. So if the difference in temperature increases, the EMF induced is also increases, and the value of the constant A depends upon the materials used in the thermocouple. So for the construction of thermocouple, different combinations of metals are used. So the different combinations of metals like copper plus constantan, chromal plus constantan, rhodium plus iridium, tungsten plus iridium can be used. So for different combinations of metals which is used for the construction of thermocouple, different values of EMFs are induced. And for obtaining the linear relationship between the difference in temperature and the EMF induced, the value of constant B always must be small and it must be neglected, so that EMF induced will be always proportional to the difference in temperature dt for getting the linear relationship between the EMF induced and the difference in temperature. So, for selecting the type of metals which is used for construction of thermocouple, the temperature range to be measured should be considered while selecting the metals used for construction of thermocouple, and also the type of atmosphere where these metals are used for measuring the temperature must also be considered while choosing the type of metals. Next, let us see the advantages of thermocouple. So, this thermocouple follows the temperature change with a small lag. So, it follows the temperature change with a small lag. So, it is convenient for measuring the temperature at one particular piece of apparatus. It follows the temperature change within a small lag, so it is convenient for measuring the temperature at one particular point in a piece of apparatus. And the second advantage is it is cheaper when compared to other resistance thermometers. These are the two advantages of thermocouple. Next, we will see the disadvantages of thermocouple. So, thermocouple has low accuracy, hence it cannot be used for precision work. So, in the measurement of temperature where very high precision is required, this thermocouples cannot be used because it has very low accuracy. And the second one is it should be protected, that is it should be shielded to ensure long life. So, the thermocouple should be protected or shielded in order to protect it from the external stray environmental conditions and electric fields and magnetic fields for long life. And third one is it is placed remote from measuring device. So, it is placed remote from the measuring device because the measuring device is placed in one place and the thermocouple which is used to measure the temperature is placed in another place, and these are connected with the help of this connecting wires. So, it is placed at different places. So, these are all the disadvantages of thermocouple.